Okay, in this session, we will do ligand sketch. So in ligand sketch, you're actually transforming your 2D structure into 3D structure. The reason why we do this is when we do docking, you need to insert an input file in a PDB file format. Okay, so as you are required to download Avogadro program earlier, the reason why is because Avogadro can directly, when you sketch on this program, you can directly save it as a PDB file format. Okay, there are other way to do this, but this is the easiest one that I can teach you. Okay, let's say you have the compound, the structure of the compound in 2D. Okay, so you just open your Avogadro and sketch your compound in the black screen. Okay, on the left hand panel, you can see under drawing setting, you can just choose whatever element that you want. For example, here we deal a lot with carbon, so just click carbon and choose single bond order. So on the black screen, you just click and you will see the first carbon atom appear on the screen. And then if you want to, so the white circles are hydrogens. So if you want to extend the structure, you just click on the first carbon without releasing your mouse. You just drag and extend. So you get your second carbon atom. Okay, and you can continue doing it until you complete the whole structure. Okay, so you get the first benzene ring ready. Let's say if you want to change the atom, you want to use nitrogen. Select on the left hand panel, select nitrogen element and just click at the position where you want the nitrogen to be located. For example, here, just click. So nitrogen will be represented as blue color. Okay, same goes at the bottom here. Okay, don't worry about the hydrogen. The hydrogen will be inserted automatically. Okay, what if you want to change from single bond order to double bond order? You just click on the bond order, click double. So click on the bond, it will automatically change to double bond order. Okay, now you want to extend the structure and add another benzene ring. So again, you can change to carbon element. Okay, now you still have the double bond. You can change that to single. Choose single bond order and click on the bond. Okay, so you will now, it already changed to single bond. So you can just extend. Okay, one most important thing is you need to start clicking on the carbon circle. Okay, do not click elsewhere. For example, if you didn't click on the carbon, you will be producing a different carbon on top of the original or the previous carbon. Okay, and that will make the whole structure wrong. Okay, so you can always undo whatever you are drawing. Okay, and make sure you extend from the existed carbon available on the screen. Okay, So okay, you can complete the whole structure. Double bond here. Okay, you have another oxygen at the bottom. Okay, so more or less you have drawn exactly the 2D structure in the Avogadro program. Okay, don't worry about the size of the ring. If you draw the length of the bond is not the same, don't worry about that, because later on we will be optimizing the structure. How you will, so to optimize the structure, you go to extension, go to molecular mechanics, click on calculate energy. So the program will give you the energy value. This is the initial energy value before you optimize anything. So you can record this value just for the purpose of recording it. 250,408 kilojoule per mole. So the way you can record this is you can open up an Excel sheet like this. Okay, make a table. For example, you have let's say you have 10 compounds, you can just list out all the compounds, the name of the compound. If you don't want to use the complicated name, you can just use compound A, B, C, or compound 1, 2, 3. You can have the structure here. Okay, energy before optimization, you can put in the value here. Okay, in kilojoule per mole. Okay, so now we are going to optimize the structure. You click extension again, go to molecular mechanics. Go to optimize geometry. Okay, so now you can see the whole structure is changing, is moving and getting into a better shape. So once you done that once, you go to molecular mechanics, you go to calculate energy again. Now you will see that the energy value is in negative value. So the energy value will decrease. This this shows that the whole compound is actually optimizing. Okay, the concept behind this is if you have heard about Gibbs energy, whatever molecule given its energy value is very negative, the more negative value is more stable. Okay, so you want your compound to be the most negative value. So now you have negative 48.67. Okay, you can optimize the same structure a few times until the value unchanged. Okay, you go to optimize geometry, so you can still see it's moving a little bit. Okay, you can optimize it again, click a few times, then you can go calculation. So now the energy value becomes more negative. So now it's negative 59.6893. Okay, I'll do another time. Okay, a few more times, and then go to calculate. Okay, you can see that the value remain unchanged after a few times of optimization. So you can start recording this energy value in your table. So this the final energy value for your compound is negative 59.68. Okay, and this unit is still the same. Okay, oops. So that is how you do your ligand sketch. You transform your 2D structure into 3D structure using Avogadro program. Okay, once you have your final, you are happy with the energy value, you go to File, go to Save As. Okay, so you can save anywhere you want. Make sure you prepare a folder of its own to save all your 3D compound. Okay, let's say you put here as compound 1. Okay, and look at the save as type. Make sure you choose PDB. Even though you have other formats, make sure you choose PDB. Okay, and save that. Okay, so that's it for ligand sketch. Make sure you draw correctly and save it, optimize the structure and save it as PDB file format. Okay.